Hi guys, welcome to the e-mentoring for MM103, and I will be your mentor for this semester. My name is Sachin, and I'm a second year student at the USP in Fiji. So I will have a good session today and throughout the semester, and we'll get started. Later onwards, I'll turn off the webcam so that way the recording and you'll be able to hear me better, so there won't be any disruption in our connection. So I hope that's fine with you guys. Thanks. Today, we will just go over two chapters which have already been covered, chapter 1 and 2 of mechanics. The first one will be on statics, and the other one on static particles. So, on the first one, on the first chapter is only theory, so I will discuss that with you. And just a few things that you should know, because usually in the papers or final exams, they give a small amount of marks towards theory. And your theory questions come mainly from chapter 1 and a few from here and there in chapter 3 and 4. I'll let you know that, so on. So the first thing I'd like to talk about is, what is mechanics? I'm sure you already saw it in your lecture notes. And mechanics is basically the science which describes and predicts the conditions of rest or motion of bodies under the action of force. A small and simple definition, guys. So, moving on. For static particles and statics, there are a few principles that you need to know. The first one is the parallelogram law. And this law states that two forces acting on a particle may be replaced by a single force. So if you have one force acting, say, in this direction and another force acting in that direction, you can add them together. That's basically what it means, the parallelogram law. You replace it by a single resultant force. Okay, now the principle of transmissibility, this is our second principle. This basically means, let's say if I have a car, and what I want to do is I'm pushing the car from the back, or I pull it from the front with the same amount of force. It's the same thing. Hence, the name of principle of transmissibility. You push from the back or the front, push from the back or pull from the front, it will be the same thing. Moving on, now we come to Newton's equations, Newton's first law, second law, and third law, which fall under the principles of, the fundamental principles of statics. The first one is Newton's first law. If the resultant force on a particle is zero, the particle will remain at rest, or continue to move in a straight line. So basically, if it is at rest or moving in a straight line, it will remain that way. Newton's second law now, if the resultant force is not zero, the particle will have an acceleration proportional to the resultant. And finally, Newton's third law, and my favorite law, to every action there is an equal and opposite reaction. So if we have a beam, we push from the top, right? If we're pushing from the top, there'll be an upward force opposing it. A very simple law, to every action there is an equal and opposite reaction. And finally, Newton's law of gravitation. Two particles are attracted to each other through equal and opposite forces. This concept can be applied to our planets or solar systems, the moon and earth, or the earth and sun. They're equally and oppositely attracted to each other. So moving on, those are just some theoretical problems or statements. Now, I'll move on to the next thing. It's the method of problem solution. Whenever we talk about solving a problem, there are a few steps that we have to follow. These steps are pretty straightforward and simple to follow, and there are 4 of them. So I'll list them down for you, and maybe you could just take note of this, so that way whenever you're trying to analyze or solve something, you may be able to follow this procedure. The first one is the problem statement. Basically, just try and figure out what you're trying to solve. Are you trying to fix a desk, or is it a chair? Anything of the sort. List your problem down. That's number 1. Number 2, a free body diagram. Draw what you need to, basically draw what you need to solve. So if you have a broken chair, you're going to draw a free body diagram of how the chair should look, how you want it, and so on. Okay. Now we'll be going over the fundamental principles. The fundamental principles we just talked about earlier. There were 6 of them. The parallelogram law, the transmissibility, Newton's first law, second law, third law, and so on. And finally, we have the solution check. So these are the 4 statements. Usually, whenever a question is asked, it'll be simple, such as, what are the methods of solving a problem? That question is quite common. I've seen it in a few past year papers, and especially your short test. So you just list down the problem statement, number 1, the free body diagram, 2, fundamental principles, 3, and your solution check. So that covers up your chapter 1, I believe, and it's pretty straightforward. And I hope you take note of just a few of the statements that I made, because you will be asked a few questions. This unit is mainly on calculations, drawings, heavy on maths. Don't worry, I'll help you through that. But yeah, just for chapter 1, know your theory, please. And now I will be moving on to chapter 2. I think now I will turn off my mic because, my webcam, so that way I will be begin to draw on the presentation board, and I will just list down the steps of how to solve each and every problem. Alright, turn this off now. Okay, so as you can see, I have uploaded a question. You have a bolt, which is, of course, bolted down, and you have 2 forces pulling on it. You have Q and P. So what are we going to do to solve this? The question is, the 2 forces act on a bolt at A, determine their resultant. Now what we're going to do is, you can move one of these forces to each other, basically vector addition. So what I will do is, I will move this force P, which is at an angle of 20 degrees, to force Q. So now that we move it here, there we go, and it has made an angle of 20 degrees here. Oh. This is force P. Okay, so now, once this is done, let me just change colors so that way you're able to tell what is the resultant. I think I'll make my resultant blue. Okay, so the resultant now will join point P. This is your resultant. So you have Q at an angle of, the total angle of Q is at 45 degrees. Sorry about this, guys. Next time I will have it written for you. But yes, you will have angle Q at 45 degrees and angle P where it has been moved at an angle of 20 degrees. And then you simply join a line to point P, and that will be known as your resultant, R. Right. So I'll just remove all this. So now that you have an idea where P has been moved and what your resultant will look like, we can solve this using one of the triangular equations. And that I will type in the box. It's pretty easy. A squared is equal to B squared plus C squared minus 2bc cos theta. I'll call theta Q. There you guys go. So what this equation is for is, we know two sides and one angle. This will help us to solve for our resultant. Right? So we have Q at 60 newtons, and P at 40 newtons. So what I will do is, and by the way, we're looking for A squared. So I can write down D, which is, I will call it 60 newtons, squared plus 40 newtons. If you look on the chat box, you'll see what I've done, what I've replaced the variables with. And 40. Cos. Okay, and now our theta. This is the main part. Our theta if you remember earlier, I called this 20 degrees. Because we moved Q up there, and then we joined our resultant. So we want to find the overall angle of this. Okay, so now that we know this angle P has made is 20 degrees, sorry guys, if you could just give me a moment. Just trying to look for something. Right, okay, so we have our P at an angle of 20 degrees, and we have our angle Q at a total of 45 degrees. We are now looking for this angle, this overall angle. And this overall angle comes to 155. I'll show you that in a minute. 55 degrees. Why 155? Why 155? This is 20. This total angle is 45. And this angle will be 45, and then if you sum them together, you will get 155. Just a moment, and I'll check. So if you look in the chat box, I've replaced all variables with the proper magnitudes of the question. So I've replaced B with 60 newtons, C with 40 newtons, and so on, and my theta at 155 degrees. Now, if you simply input this into a calculator, you will get an answer of about 98 newtons. I hope if you just check this on the calculator to clarify, and you should get this answer. This question is also from your lecture notes. I will be going... So the only thing we are left to find now is our theta. We found 98 newtons. We found our magnitude of the resultant, and now we need to find the angle at which it makes with the ground. So I will call this, say, alpha. And in order to find that, we can use the sine laws. Those are A over, I'll list this, we have an A capital B, and a capital C. I will call the edges, the opposite edges, I'll call this small a. This would be small b, and this would be small c. So according to the laws, it is sorry guys. Okay, I'm just typing the formula of the sine law, which is small a over sine capital A, which is equal to B over sine capital B, and also equal to C over sine capital C. If you look in the chat box, that is the formula. And now what I will do is I will replace the variables with the magnitudes. So basically we are trying to find our alpha angle, and that I will replace small a with 60 newtons over an angle of 25 degrees, which is equal to our small b, which is, I'll call a 40 newtons over sine 25 degrees, which is equal to 60 newtons over sine, that would be sine 155 degrees. So if you look at that, these two equal to each other, then now we are left with small c over sine capital C. And we know our small c, which is now our resultant, 98 newtons, over sine capital C. So if you equate these all to each other, you'll be able to solve for C. Let me do that for you. So I will equate 60 over sine 155, which is equal to 98 over sine C. So 60 over sine 155 would be 60 newtons divided by 155 would be 141.97, which is equal to our 98 newtons over sine C. We are solving for C, so we could multiply C to the left hand side and divide 98 by 141. So 98 over 141.97 is equal to sine C. Once you find the inverse, sine inverse of 98 over 141, you will be able to find your angle, which becomes 35.07 degrees. And there you have it. So guys, this is just one question from chapter 2 that I've gone over. And hopefully from next week we'll be able to go over more, and I hope to see you all there. So if there are any questions, you could ask now, and I'll prepare them for next week. That way we could discuss what you'd like to go over as well. And yeah, I hope that helps. Thank you guys. Bye.